In this question, we see the absolute value symbol again. It says that S is the set of all integers x that satisfy the inequality absolute value of x is between 1 and 6 inclusive. Quantity A is the absolute value of the greatest integer in the set, and quantity B is the absolute value of the least integer in S. So the set S, this is a set notation. You have a curly bracket, and you just have to think about numbers that go inside this set S. Obviously, x can be 1. So what is absolute value of 1? That's equal to 1, and that satisfies this condition. It can be 2, 3, 4, 5, and 6, as you can see. All of them satisfy this condition. So what about 0? 0 actually does not work. And 7, of course, does not work. If you put 7, well, can x be 7? The answer is no, because absolute value of 7 is 7, and that is greater than 6, not less than 6. 0 cannot be the answer because absolute value of 0 is equal to 0, and 0 is not between 1 and 6. But negative 1 is a possibility because what is absolute value of negative 1? That is 1. So therefore that's just equal to 1, so that satisfies this condition. So does negative 2, negative 3, negative 4, negative 5, all the way up to negative 6. And I believe that these are all possible integers that can satisfy this condition. So this question was all about finding this set and what the elements are for this set. Each of these is an element of the set S. So let's have a look at the greatest integer in S. So the greatest integer is 6. Okay, so that's the greatest. And what's the least integer in this case? The least integer, is negative 6. So what is the absolute value of the least integer in S? So that's negative absolute value of negative 6, that is equal to 6. And what is the absolute value of the greatest integer? That's absolute value of 6, and that is equal to 6. And we can see that these two quantities are equal, so therefore the answer is C. In this question, we were able to include the numbers 1 and 6 and negative 1 and negative 6 because of this inequality sign that includes the equal symbol there. But however, if the condition was between 6 and 1 but without the equal sign, then the set would have looked different. So you can see that the 1 is not possible because 1 is actually, so the absolute value of x has to be greater than 1, can never equal to 1. So 1 is out. But 2 is okay, and 3 is okay, 4 and 5, but not 6, because if you put 6 into this absolute value function, you get absolute value of 6, but that is not less than 6, that is indeed equal to 6. 0, of course, as I explained before, is not a possibility. Negative 1 is not possible either. Negative 2 is possible, negative 3, negative 4, and negative 5. So this set would have been the set satisfying if the condition for the absolute value of x was this one rather than this one here.